Okay, guys. So now we are in today's lead code contest. This was weekly 3:30. Okay, let's start the first problem. Recording on, yeah. Start the first problem. Very simple problem. Count the distinct number on the boards. You have been given a number n, and you have to return a number. Let's say x. This x is basically you have been given a number n initially placed on the board, and every day, you know what you do, or for you can say infinite days, what you perform an operation. You choose all the numbers that are x modulo I is equal to 1, which is, let's say, this number x you choose, which is basically a remainder. This number no, x is present on the board. You choose a number I between 1 to n. Okay, and check if its remainder from this x is equal to 1, then you add those number onto the board. For an example, yeah, that was a simple code for this, but yeah, let's try to figure it out how this is happening. So example, you have been given 8. Then what you will do, you will choose any number which have modulus 8 equal to 1. 7 has no, like what I'm saying, key, let's say x is a number 8 modulo x equal to 1. Yeah, you have to see all those number which give a remainder, no, from which 8 gives remainder equal to 1. So that is only one number, 7 in this case. So you will put 7, then you will put 6, then you will put 5, then you will put 4, then you will put 3, then 2, and then 1, right? You cannot place anything like 1 modulo x is equal to 1. Someone some number, when you divide 1 from that number, the remainder is 1. No, that is no such number. Even 0 divided by 1 is equal to 0, right? So 0 is also, you can say, a perfect divisor of or let's say 1 divided by 0 is not defined, like it's not defined, it's not equal to 1. But if you talk about one other any number, 1 mod 1 is equal to 0, 1 mod 2 is equal to what it is 1 1 mod 2 is equal to 1, I think. Yeah, is equal to 1. So this is giving one remainder. 1 mod 3 is equal to what? 1. So this will always be 1, and 1 can give you numbers like 2, 3, 4, 5, 6, 7, 8, anything. But yeah, that's about it. You can have all the numbers till n minus 1, just don't that number. And yeah, these are the numbers which you have. How many numbers in total that you have? You have 4 numbers in this case. But when the answer is 1, how many numbers you have? Like, yeah, one number you have. When the answer is 5, you have 5 minus 1, because that is the number from 2, 3, 4, 5. Yeah, these are the 4 numbers you have. Why you can't have 1? Because when you have 2, you are saying that 2 modulus x is equal to 1. 1 perfectly divides 2. Okay, so if 1, you cannot have 1, because then it is 0. So that is why on all of the number you cannot have 1. Otherwise you can have like n minus 1. That is the answer in this case. But when answer is 1, you have the 1. And let's go to problem number 2. Yeah, these kind of problem I was really frustrated. Like, I got WA in this also. You can think I can get W, but yeah, that was really simple problem. Just an observation, I would just say. It's a code forces type observation problem. Just see one or two example, you'll say ki n minus 1 is the answer. And why I'm saying this, because problem 2 is more of that observation problem. I don't know 5 6 how many WA I got, but it was very simple. Like, you have been given a polygon, you need to return a number. What number, they haven't mentioned that also clearly. The collision volition they have mentioned, but yeah, it doesn't make much sense. So basically you have been given some, let's say, polygon containing n side, n vertices, regular polygon, you can think it's, and you have n minus 1 clockwise direction. Okay, exactly one monkey on each vertex. Now what these monkeys are doing, they are jumping, or like what are they doing? They are moving. Yeah, they are moving, I think. uh, Reside on the same vertex after the collision. Each monkey can move only one. So I think they are moving from one vertex to another vertex. And let's say 0 goes to 1, 1 goes to 0. In between, the collision will happen of the monkeys, right? So you have to return all those times the number of collision will happen. I can just tell you the total number of moves that monkey can move is, for example, 0. How many moves is a 0 can take? A monkey present at 0 can take. He can move to either 1, he can move to either 5. Every vertex has 2 moves, so total moves is equal to 2 raised power n. You need to tell that how many ways they will collide, right? That at least one collision will happen. So out of this 2 minus 1 ways, 2 raised power n ways, Yeah, just there are two ways when no one will collide, right? There are two ways only when no one will collide. Which are these two ways? I think you are smart enough to guess. Like when all move in the same direction: 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 0. So this perfect circle they are following up. So no one is touching anyone, right? Everyone is just moving in forward, 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 or everyone is moving backward, backward, backward. No one is colliding with anyone. So these are the two ways no one will collide. So answer of collision is equal to 2 e power n minus 2. This took a while to understand, but it was really simple. And now I'm thinking it's not observation based, guys. It's pure logic, like what you have to think out. Like there are only two ways when no one will collide, and other ways all will collide. So yeah, it was not much of an observation, but yeah, that's a simple power of two. Yeah, this is a binary power function. I don't know why I use that. I use that because obviously the reasons are obvious that power can be huge, like at 10 is per 9. I don't know, like really is it or not, but yeah, power can be huge, so that's why you have to use binary power. Also they have mentioned mod also, so that's pretty fine with it. So and then plus yeah, this is nothing but 2 raised power n minus 2 in terms of mod. And then that's what you need to return. Let's submit this up, then it would be fine. Like let's move to problem number 3. 6 minutes to go. Yeah, is it fine? Yes, accepted. Okay, let's see. You can think out. Basically, this logic was very good. Not very good, but yeah, fine. And then this is the third problem. Put marbles in a bag. This is actually kind of a data structure kind of a question. First question in the lead code contest. Like why lead code is going more over like code forces contest now, but yeah, it's fine. Third question is also hard difficulty. No complaints about that. But yeah, how many people solved it? Like yeah, majority people solved it. And then it was really simple for me, I think, because like I did this in just 10 minutes. I don't know, like it was really simple if you just crack the observation. Like for if you are going in a way that question wants to you to go, then it is just 2 minutes of logic and then implementation, how fast you are, right? It's just 2 minutes of logic, maybe less than that for someone, because yeah, that's how they perform, right? And then you have been given a weights array and then k is equal to 2. So weight array is basically an integer in the array and having some weight of I, right? Ith element is the weight of the ith marble, and then what you have to do, you have to split this array into k parts. Obviously the good splitting is there, like very decent splitting, like our continuous splitting. It's not like you are picking any random indexes. Okay, so no bag is empty, ith and j marble when the index. Okay, so basically this line says there is continuous splitting if I is there and j is there, so all the elements between I and j will also be in the same bag. So I to j is basically a window that is the same bag, you can say. And then a bag consists of marble. Okay, so this is the cost of a bag. They have defined cost of a bag is the cost of starting element plus cost of the last element, right? If this window or this bag contains I to j elements, continuous elements, so I plus j, right? So score, you have to say what is the score of the cost of score is the sum of sum of the cost of all k bags that you formed, right? Now you want the difference between maximum and minimum. At the first go, it was looking like a binary search. It can look like a binary search because when you have to do max of minimum, minimum of maximum, that's binary search. But no, it's not maximum. It's maximum and minimum. So what is the maximum score that you can have by dividing this? Let's just try to figure it out. That if you have some weight array like this, you want to split it in two parts. Okay, you can split around this index, you can split around this index, or you can split around this index. These are the two possibilities. But when the stakes are, when the k is high, the splitting would be not that easy. But yeah, but when you split around this index, see what the cost is coming up. Cost is coming up as the cost of 1 plus 3 plus my cost of 5 plus 1. Okay, so this is giving maximum. I don't know, like yeah, yes, it is giving maximum, but yeah, but it's not like logic is basically that, even if you split around any index, let's say you split around, let's say 1 comma 3. So what is the cost of this? You will get 1, for sure you will get 1, and you will also get 3, for sure you will get 3. You can get some any number x, right? It is the ending window of this 3. But what is sure that you will get two adjacent elements. This is purely sure because when you break a window, so let's say like just talk in more general terms, like a b c d are there, e f g h. If you try to break a two bags at this point, c is for sure going in the for the bag, let's say bag x. For bag x, c is going for bag x. Bag x value would be something like, let's say a random value, let's say r1 plus c. This would be for sure the value of bx, because you are breaking this around this index, so last element has to come, so c has to come. And let's say this is by, So by the next bag, the just b of x plus 1 would surely have something like d plus a random value 2, which I don't know about, but these two adjacent element will always be there. And on obviously the first element will always be there, like one has to be there because it's the very beginning. So I am fixing some number, so one is obviously going to come. Then let's say some number a of I is going to come, then I'm saying that a of I plus 1 will come for sure. Then let's say a of j will come, then I'm saying a of j will come for sure. Then I'm saying let's say a of k is coming, then I'll say a of k plus 1 is come for sure. And so on, so on, so on. This can be any many like the number of splits that you are making, like number of last split ls and ls plus 1, ls plus 1. Now ls plus 1 value is also known, it is would be the n minus 1. Why? Because yeah, that's what it is. You have to take all the elements into the bag. I think that is also mentioned. Yeah, yeah, that's you can consider. You have to take all the elements, and then last one will always be there because it's the ending point of the last bag. So this is fixed, this one is fixed, and all other numbers are total n minus 1 number, or how many numbers. So for example, you have like this is 1 bag, 2 bag, 3 bag, 4 bag. I did over here, how many bags I drawn over here? One, and then it's 2 bag, and then it's a third bag, and then it's a fourth bag, and then it's a uh, okay, L A of L s plus 1. Let's take it as s plus 1. This is sixth bag, right? One. How many are there, man? One bag. Basically, what I'm trying to show, how many bags will be forming would be k by 2, something like that. No, or something like that. What? K minus 1 bags will be forming. Ha. 1 and 2 and 3 and 4 and 5. 5 bags you're forming. And how many numbers you have chosen, like how many adjacent elements you have chosen, like one adjacent pair, second adjacent pair, third adjacent pair, fourth adjacent pair. You have chosen four adjacent pair. That is for sure it'll always gonna happen if you want to, let's say, make n splits, right? Two, three, four, five. Let's say you want to make five splits. How many adjacent elements are gonna come? This is fixed one. So two elements around this point, 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 and two elements around this point. So if five splits are there, like actual splits, like irrespective of the last index and the first index, five splits, then five adjacent you have to take. But if you do five splits, how many total partitions you created? It's equal to six partition. Everyone knows that when there is n partition, you have to take n minus one split. One, two, three, four, five, six. I can see six partitions. If you can number it also, it would be good for you, right? One, two, three, four, five, six. These are the six splitting, and six partition, five splitting, and five adjacent elements indexes I have to take. So what I did is basically take the sum of all adjacent, and then choose k minus one of your liking, like what you want, of your wanting, whatever. Whew. Somewhere you want maximum, then you want minimum, so you take both. Now you have to choose sum of adjacent element, and then you have to pick k minus 1 maximum out of it, k minus 1 minimum out of it. To pick max and min, it's for sure binary search. No, priority queue. To pick max comma min, like k max k min, these kind of question, everyone have done this in UKG or what. To pick k max k min, you use PQ, priority queue, right? And that is all logic about this problem. You will store some of the adjacent element once in max heap and once in min heap, right? And then you take whatever you want to take, max heap minus min heap difference. Like now you got the logic why I'm doing, how I'm doing splitting, how adjacent elements are involving, how adjacent elements sum is mattering, like which is greater, which is smaller, all the greater top k minus 1 elements you choose from the priority queue, and minimum k minus 1 elements. So let me do it for you. Priority queue into Q1. Okay, priority QUE into Q2, but it is min heap. Iter of int Hey, yaar, what is this issue in indexing orientation? Now, for how you are going to take adjacent elements, and I is equal to 0, I is less than n minus 1, I plus plus, and I'm saying q1 dot push q1 dot push this, q2 dot push that, top k minus 1 element. How you'll find out? Let's say entity is equal to k minus 1 while t minus minus. You have pushed your max heap min heap. Taking out elements from the max heap would be like int top k or like max k. Yeah, max k splits max k what? Let's say you can say max score because that's what are you looking for. Max score is equal to min score equal to 0, and max score plus equal to q1 dot top dot pop min score plus equal to pop pop. After this, what you need to do, return anything else. Max score n is not declared as always. W dot size k n top element like 10 lines of code. ठीक है q1 q2 max score min score 4 4. Let's submit. 17 minutes, decent. Okay, long, so take long. Accepted. Okay guys, that's about it. Bye.